Hi everyone, how are we doing? Great. So don't you think the only thing better than being in that picture is being at this conference? Anyway, so I come to a lot of these conferences, and so do you, I guess. I often see one thing that's missing, and that's coverage of enterprise applications and how you build enterprise applications, especially web-based mobile enterprise application. And that's one of the reasons why I really wanted to talk about this. My name is Manish Garg. I work at SAP. It's one of the largest companies that make enterprise software. Some of you might have heard of it. Who here works at large companies that make software, like large enterprise software? That's a fair. And those of you who don't, do you use software from large enterprises? Web-based, mobile-based? Maybe even if you don't realize you do, because if you do online banking, if you pay your utilities bills, if you do any of those things, then you're already doing it, right? So it affects all of us. And I'm an architect at SAP. I have primarily been working on web applications, and for some time now also on web-based mobile applications for the kind of applications that we build. And we built quite a few of these now, over 100 applications on mobile, web-based. I want to focus a little bit today on our experiences building these applications, real-life examples, real-life experiences, what it was like, where were some of the pitfalls, what were some of the things we did not expect, some of the gotchas that I thought, in my opinion, worth mentioning. So we are going to talk a little bit about what are enterprise applications, because not everyone really understands it. So I want to talk a little bit about that to set the context. I want to talk about native versus web-based mobile applications, because whenever we talk about mobile applications and we are going to commit to one strategy or the other, it's always a question of which one do we want to do. So that's how do you build an enterprise application, right? Native or web. And then I want to talk a little bit about performance. And I also want to talk about this topic on customizing your applications, which is very important for any enterprise applications. Again, I don't think this is a topic that is very well covered by most JavaScript libraries today. And I really want to talk about that because to me, it was insightful how important this is and what needs to be done in order to address this. So before we even talk about what enterprise applications are, some of you might be aware and some may not be, but there are a lot of different trends that are happening in the enterprise world that influence how we build enterprise applications. Consumerization of IT, democratization of IT, meaning you as people who work at large companies and me, we have more choices now, right? We are not necessarily slaves to all the tools that IT gives us. I can go to AWS and spin up my own server. I can use Dropbox and share my files. I can use Basecamp to do some project planning. I can use GitHub to put my code in there. So I have access to all of those things, right? So the doors are opening up a little bit now. Partially as a result of that, and also partially because companies are also realizing it on their own, there's a huge shift from very heavy feature and functionality-based applications towards applications which are more design-focused, applications which are more beautiful to consume, and they just feel much nicer, more like consumer applications. I mean, at the end of the day, you and I, whoever works in enterprise companies, are also consumers, right? At home, we consume all kinds of stuff on the net, and when we go inside the four walls of our companies, we probably expect similar experience now. And so the same people are making these decisions, and it's not a big surprise. Mobile device and the usage of your mobile device, and especially the fact that many companies allow you to bring your own devices and connect them to the corporate IT, has a huge impact on the way software is being built and what companies are doing to address it. Because imagine all the different platforms. So we've got 3-4 different OSs, iOS, Android, Windows, so on. And then on each of them, we've got multiple form factors, tablets, phones, multiple browsers. In order to support all of that, IT really needs to think about what they need to do. So that's another big thing that's happening. And finally, this ties up to the first point. Companies which provide consumer-based applications have direct access to employees who are sitting behind enterprise applications, right? They don't always have to go through IT. Just like how we were talking, AWS doesn't have to do anything. Amazon doesn't have to do anything to give you the AWS service. You can have it today. So there's already this direct connection. And to some extent, enterprises have to kind of compete with these things, compete with this experience, compete with these offerings. And these are the huge trends that are happening right now. So it's a really interesting time for enterprises and building enterprise applications. Enterprise applications, I was having lunch and I was just talking with somebody, and I don't know if they're here, but they asked me, so enterprise applications, so you guys do a lot of accounting software. Yeah, but that's maybe 2% of what we do, or I don't know what percent. But enterprise applications means running all the mission critical applications for large companies, running the supply chain, running the HR processes, running the payrolls, running accounting. You order a laptop at work, it goes through some system, it goes through a process till it reaches a vendor, and then the vendor ships it back to you. The whole thing is tracked. How does all that happen? So all of that happens through enterprise software, right? If enterprise software came to standstill, we would not be able to get our chocolate, we would not be able to get our wine, we wouldn't get our designer jeans, Nike wouldn't know where to ship which shoes, and which shoe is the next one they should make. Things would just break down. So these are really important applications that really make things work. Sometimes we just don't realize, but it has a huge impact on all of us. And it can get pretty serious business, right? Because there are thousands of companies which are running several processes, and your application has to serve the needs of these companies. Even if it's accounting software, companies use it differently. They do different things with their accounting packages, and even the same company within different countries would do something different with it. So your software has to be able to handle all of that complexity. It has to be customizable, as the fourth point that I would talk about in the overall presentation. With all that, of course, there are some differences between an enterprise application and a consumer application. So enterprise applications typically are not just single applications. These are a suite of applications that you offer. And since it's a suite of applications, the user experience and the design and the consistency of the application has to be there across all the applications. So a user who's using your accounting software or your HR or whatever it is that you do, it has to just feel the same way. People have to know how to use the software. So the consistent, so it has to be very design driven, right? Just because it's a web application doesn't mean it's hosted. Many times enterprise applications, actually most times it's shipped, even web applications, because large enterprises like to run it on their own premise, within their own IT landscape. They don't want to host it. And that has a really big implication, and I've underlined it because this is often looked, people don't pay too much attention maybe. But when you're shipping software, it means you have to maintain release cycles across all of your software. It means your internal dev cycles have to kind of fall one after another because you're going to ship something. It means that even a small bug in your system can be very, very expensive to fix, because now you've handed something over to a customer and you get a call that something doesn't work. So you have to fix it there, but then you also realize, oh, this problem probably exists in all the customer landscapes. And that suddenly becomes a huge problem to fix. If it's hosted, you go online to your code base, wherever that is, you fix it, you deploy it, and things are rosy again. So the fact that it may not be hosted is a huge impact. As we were talking, applications need to behave differently for each company, and then within each company across different geographies and different verticals, they need to behave differently. So, which means the applications need to be extensible. You need to be able to make the same application behave and look differently under different circumstances. Customers may want to put their own logos, their own design, their own content and data and tags and so on. We'll talk about that a little bit in detail later. Of course, your application has to be very robust, responsive. You have to be able to integrate into the user management or whatever LDAP the companies have. So it needs to be able to handle all of those things. You're going to upgrade your applications. There's going to be some maintenance downtime, and you have to manage that. And it's very important because what happens when an American Airlines reservation system is down for 1 hour for maintenance? You have to really plan for that, right? That can mean a huge revenue for them. So this is very important. And of course, security, authentication, authorization, all of these things. So that makes, and these things are a little bit more complex, so that makes enterprise applications a little bit different from many consumer applications. Many well-architected and well-built consumer applications probably follow a lot of these anyways. It's not always different, but there are differences. And because there are differences, there are architectural impacts of that. Architectural impacts of these differences. You have to have a responsive design, which means to give a consistent user experience across all your devices, across all the form factors and desktop. You have to build nice responsive web applications. You have to have very good support for security, single sign-on. Sorry, I should not have written SSO, single sign-on. You have to support globalization and internationalization, which means your text is translated when somebody is loading it in Japan versus here. And it also means that your currencies are automatically, your units of measurements are also getting converted. So you use pounds in England, and you use dollars in US, and you use yen in Japan, and so on. So those things are seamless to the end user by detecting the locale of the browser. So you have to think of all of those things. The next 3 points, they are in bold because I'm going to dig a little bit deeper into these things. So what is native versus web, because that's an architectural impact, performance, and how do you customize applications. We talked that your application has to integrate with the rest of the landscape of a user. How do they make their applications talk to each other? What is their overall backup strategy? What is their authentication, security, all of those things. So it has to integrate with all of that. And if you're shipping something, especially web applications, there are high chances that you have open source in there, which is fine as long as you're following all the legal compliances behind that and how it's licensed. But you have to think about it, because in the hosted world, you're not shipping anything, and that may not be such a big constraint. So when I started looking into web applications, mobile-based web applications, this was a very big question, because we were going to commit a huge number of resources on this. And it really depends on your use case, right? What I found is it's not a silver bullet. There's no one right answer. It depends on what you want to do. There are pros and cons in doing HTML5 based mobile applications or doing native applications. For enterprise applications, I think HTML5 is a great choice, and that's my opinion. What I found was 80% of our use cases can be done with HTML5 with web-based scenarios, including graphs and analytics. So we do a lot of analytics and graphs and interactive graphs where people can drill down into details and the graphs are dynamic. All of that is fine. All of that is great. 20% of it, I think, still needs native support. Things like image processing or barcode scanning, access to hardware features, file streaming, offline support. You want to store things offline. I don't think web applications are quite there yet. Also because maybe some browsers have implemented, the specs are all there, right? The HTML5 specs are there to do everything, but the browsers may not have implemented all of these specs, and that's one of the problems. And to me, a phone really is a physical and a intellectual augmentation to yourself. At least that's what it should be. And as a knowledge worker, if I'm on a manufacturing line, and if I'm not able to scan what I'm doing because I have to enter this detail, scanning it would be a much faster way. But if my application is not able to do that, then I don't think the app that I built serves his purpose. So for that, I think for us, what I'm thinking, I'm leaning towards is why not just have 20% native support? So build a native web container around what we build. And for the time being, till the browsers are all going to support everything that we need, you can do that through native. It's not a deal breaker. If I have a little bit of native wrapper around my application, I can do barcode scanning, I can do a lot of other things, hardware acceleration, offline caching of files, offline caching of content. I can preload all my libraries, I can improve performance, I can do many things. So that's where I am at that. But again, as I said, it depends on your use case. It may be right for some, it may not be right for some. So from design perspective, I think doing HTML5 can give you really good, nice, consistent user experience, because you build your web application once, you have one CSS, through media queries, you make it responsive, and now through some other magic, you can make it work on all of the devices, at least the devices that you want to support. With native, no matter how hard you try, an Android app and an iOS app and a Windows app would look different. Sometimes subtle differences and sometimes not so subtle differences. And that's really not pleasant, right? So from design perspective, I think it's great. And the second one that I did not know upfront, but it was a sort of aha for me, is when designers are working on the assets, and by assets I mean your HTML theme and your CSS and images. Images you can reuse in native also, but the other assets you can just reuse in your web application, right? I can take the HTML that my designer built and I can have my developer do that. But with native application, even a very high fidelity mockup that a designer would do, still a developer would need to code everything down in a native application. So that's a huge plus for me. But at the same time, you don't get some of the design experiences that I would hope a good application has, like animations. And by animation, I don't mean images jumping around and ducks flying around, but I mean nice, smooth screen transitions, nice, smooth pop-ups, scrolling, drop-downs, things that you just expect in most applications. It's a little bit clunky, sometimes even a performance hit. And because of that, we had to sometimes change our design to accommodate for that. So if barcode scanning is not supported, then we change the design and do something else for the time being. And if my design is very dependent on the technology, then to me, the technology is not there yet. And of course, performance. And I like to put performance in design, because if it's not performant, then the whole design and the user experience suffers no matter what. During development and testing, for sure, the development time and cost is much lower if you're doing HTML apps, simply because you have one code line that you're dealing with. You just build one, we have one code line to deal with all of the devices. You handle everything else by doing some tweaks in your JavaScript or CSS, but mostly it's one code line. Imagine having multiple code lines for each of the operating systems, and then having multiple versions of that. So suddenly your matrix becomes a huge matrix to support. And if you've got large teams working across different geographical locations, I found that web applications are much easier to develop in that environment, simply because if my colleague in France or Budapest tells me, hey, Manish, I have a problem in my app, can you have a look? He just hosts it somewhere, right? So it's hosted, it's running, I go in there through browser debugging, I can look at it. For a native app, I have to get it, I have to install it on my phone or my emulator and then get it to run. So there are many more things I need to do, which I don't need to. So it becomes much faster. And testing is definitely easier. It's still not easy. It was a bigger pain than I would have imagined or thought, simply because some things that I thought the Chrome or Safari browser, the way they behave on desktop is more or less the way they will behave on my mobile device. But that did not turn out to be how it was. There were many things that we did not expect, and I'll talk a little bit about some of them. So now imagine you've got all these devices and all these form factors and all these different browsers. And if you draw the matrix, 5, 6, 10 browsers across different devices, and you have to kind of test across all of them. So testing is a challenge. And some things that would be very simple you would expect can sometimes turn into a nightmare if you've not done that before, or you just don't expect it to work that way. Scrolling, it's a very typical user pattern where you put a tab bar at the bottom of your screen on your mobile applications, right? Where you just click for main functions. It's like the menu. Just sticking it to the bottom of your screen, you would think it just works. It doesn't sometimes. You have to use a library to do that. And why you have to use a library to do that? And as I was talking, testing across all the devices is still, I don't think it's there. Just simple things, right? I had a scenario where there were pop-ups. So there was one pop-up, and you click on that, there's another pop-up. And it worked fine, even on an iPad, and then on most phones. But on one particular phone, on one particular browser, the pop-up would come consistently behind the other pop-up. And if you have not tested that, there's no way for you to know that. And you think, okay, I've tested 80% of my devices, I'm there. And your user sees that behavior, and it's not pleasant. Lifecycle management of your applications. It's one code base to maintain, so it's very nice. I like that because I can keep releasing subsequent release cycles of that. It's easier to distribute. I don't have to go through all the app stores and all of that. I can just distribute it. And think of your desktop, right? Even though you're building mobile applications in an enterprise environment, you still have to think of the desktop. If you build a native iOS or Android application, what do you do for your desktop? Do you build another app for your desktop, or do you do web for desktop? What do you do? If you do web, it's automatically taken care of, right? I mean, of course, there is some CSS and some other stuff, but more or less it's taken care of. So that's big. And this technology is rapidly evolving. So in the cons, I've said things are changing rapidly, and that's because technology is really evolving right now. Browsers are making a lot of progress. So with all of that, things are still, I'm not sure 1 year from now, what would my app look like? What would I have to do with my app to support what the browsers have 1 year from now? So there's a little bit of uncertainty out there, but I'm willing to live with that. So that's a little bit about native versus HTML applications. And as I said, one may be right for you, and I'm not saying one is right or wrong, just my personal take on this. So we looked at what enterprise applications are, 2 different ways to build it. If you don't have things for which you necessarily need native, you could use HTML5 now. Performance, this is a favorite topic of mine. It keeps coming up all the time. And performance is very important, right? For consumer applications, for sure, for enterprises applications as well. I think it was the last HTML5 dev conference or one of the conferences, there was a very good speaker from Google, Colt McCandless, and he was talking about this, and I was very intrigued. So let's say you've got your web application, 1,000 people are accessing your web application. They come to your web application. If your pages do not respond within the first 3 seconds, you lose about 40 to 50% of your audience. They just bounce off of your first page. Out of that, 80% do not ever return. So you've just lost 400 of your 1,000 customers or your users to performance alone, right? And it is important. And this is a very expensive problem. We also know that the mobile web application performance is not as good as a desktop web application process for obvious reasons. It's a smaller device with fewer resources. Excuse me. We also know that a mobile web application performance is not as good as a native performance sometimes, simply because native is a compiled bytecode running on your phone versus an interpreted code running on your browser is not going to be as performant. There are some obvious reasons, but I want to talk about specifically to me, what I saw were some of the big reasons behind some of the performance bottlenecks. The first and foremost, of course, is network. This is, in the best case scenario, a 3G or a 4G phone is going to give you 3-4 Mbps Um, on my desktop, it's very easy to imagine I'll get north of 10, 20 Mbps easy, right? Even 50 Mbps, 100 Mbps. And web is becoming a place full of images, rich content, media, streaming, and with such a huge difference in bandwidth, of course, there's going to be a performance hit. The compute on your mobile devices is much smaller. So your CPU, your GPU, your memory availability on your device, the technology is not as good as your desktop, and it takes more CPU cycles to compute something, or takes longer to do some same tasks that you would do on your desktop. I really think that browsers are severely lagging both in performance and functionality on your mobile devices. Even good browsers like Chrome and Safari, they've been doing a lot and they've been making huge progress, but I still think there are some things that can be addressed. And I'll talk about one specific issue right after this, which is very surprising. There's no caching in local storage, so every time some of the content has to be fetched, which can become a pain, but you could address that by doing partially a native wrapper, for example, and caching. And for your mobile browsers, the tools to debug and do profiling, memory profiling or CPU profiling, performance profiling of your applications was not quite there. Now I think there are quite a few tools out there which can help you and support you. And I'll show you some of the tools that you could use. Very simple to use, easy, free tools that every developer should know about and should be using, and I hope you all are using them. So I want to talk about this one specific problem that we face between a mobile and a web application. So there was this one page that we were testing, and the testers were reporting that there were some issues with performance only on mobile devices, and so we did some profiling. This is using Xcode, which is the IDE for building iOS applications. This was on an iPhone. The problem was reported on iOS devices. So in Xcode, you can do CPU profiling of your devices, and you can connect your mobile device to your Mac, and then Xcode will detect your mobile device, and then it will do a CPU profiling of your mobile device, and it has that capability. So it's a great thing to know and use, and it's very easy to use. So I wanted to profile doing that. So I did the profiling on my desktop, and there were some CPU, this is CPU profile, so what is my CPU doing? And there are some spikes, and that's because I was interacting with the screen, so it's fine. I expected that. And most of the times it was nice and low, and things were okay. The same thing when I did the same web page, when I render in an iPhone, suddenly I see this behavior in my CPU. There are spikes all over the place, and they're just not going away. And you see the runtime of this is much bigger than what you see in the big box in the center, 1 hour, 18 seconds. So it was running for a large amount of time, and the CPU just kept going. And I was not sure what is going on, because I'm not even touching the device and the CPU doesn't stop working. And then we found out that in the browser or somewhere there was a bug, probably, that some of the controls, and this was not on all pages across all controls, but some of the controls were constantly saying, have you resized yourself? I want to repaint myself if you have resized. Have you resized yourself? Mr. Browser, have you resized yourself? I want to repaint myself if you resized. And that just kept going. That's okay on the desktop. And the desktop and the stack trace, it said the same thing, but it didn't matter. But on the mobile device, it mattered a lot. And I don't know of anyone who resizes their browser on a mobile device. I have never done that. I don't even think you can do that. So why does a browser have that in there? Why does a browser make controls ask if they're going to resize themselves? So things like this, right? This was a very concrete example of why things are lagging on a mobile browser, how they can be improved. So we eventually solved the problem by working around the problem, but I'm sure there are many such problems out there. And this was very interesting to me. I spent a lot of time doing this, and I wanted to talk about this. So these are some of the tools that you could use to do memory or CPU profiling. Most browsers out there today have a network tab in the developer section of your browser. I'm sure you guys know what I'm talking about since you're here at this conference. If not, you can look up a network tab for developers in browser. And in that network tab, it shows you all the traffic, all the HTTP request and response, and how long is it taking and what's going on. And that's a great tool to see how many calls your web page is making. Can you put some of these calls together and make it fewer calls? Profiling functionality in your browser. So Safari has memory profiling. I'm not sure if it has CPU profiling, but you can do CPU profiling using Xcode on iOS, for example. Chrome has got both CPU and memory profiling, and things are changing all the time, so it might be different in a few days. Xcode profiling we already talked about. So Xcode is the IDE for writing writing iOS applications, and you can use that to do profiling of your mobile devices. You can connect it to your machine, and Xcode will detect your device. Chrome has a tracing functionality it gives you very good and powerful information on the performance of your application. So you just type that in your Chrome browser, and then you'll see the interface. It's very humble interface with just 1 or 2 buttons, so it doesn't look like much, but it's a very powerful functionality. There's a tool from Yahoo, Low, that's been around for quite some time. I've used it many times. You just say, okay, Low, go check the performance of this page, and it goes and it categorizes everything. You are not using CDN, content distribution network, or your content is not cached properly, your timeouts are not set properly in the header. It gives you a lot of information that will help you to improve your performance. So that's a great tool. Finally, Google Refine, which is now called Open Refine. This is not so much a performance related tool. It's just a tool where it's a web-based application, by the way, originally from Google. You can load any structured file. So your log file is a structured file, right? It has well-defined fields in there. You could load any your performance file in it, and then you can analyze it, you can sort it, you can do all kinds of things with it. And the best part is that since it's web-based, you can share it with each other. You can share the same file with your colleague without them having to reload and do all of that stuff again. So I've used that a lot to analyze the performance logs. So that's another tool that you can use. It's very easy to set up and use, and there's great instructions to do that. So that was my rant about performance. Why performance is a little bit different on mobile versus desktop and so on. And now I want to talk a little bit about customization. This is one of my favorite topics from enterprise perspective. So what happens when we show a really beautifully built, great application to our customers? Of course, they love it. But the next thing they say, but you know what, I want to change this header, I want to change this footer, I want to change the color, I don't want this. I want a table at the bottom of the screen, and I want this tab to look differently, and I want so many things to be different. And that's perfectly natural and absolutely the right expectation from a customer. And anyone who builds good applications has to think of that and has to support that in their application. And even the same customer, the way they would customize their app for their use case, for example, in accounting, they would do accounting differently in US and differently in Europe. So they would customize the software a little bit differently. So even within an enterprise, it would be different sometimes, right? So that is something your web application, any application has to support, but I'll talk about what I did with the web applications to support that. So I just talked about what customization mean. I have some screenshots to show you. So for example, here on the top, you see my mouse? Yeah. There's a field in my original app that I want to hide. That's my customer's expectation, so they can hide it. Or the original app just has empty space here because it's left empty in case the customer has to add something and they want to add a table. They can add it. But you know what's the biggest challenge of doing some of these things? I'll come back to this. What's the biggest challenge of doing some of these things? This has to be done without touching your original application. Because when you make the next release and the next release goes out to the customer, you'll overwrite everything that they did, and they have to redo all the work. So you cannot touch your original application, yet you have to somehow extend the functionality and the user interface, and that's the challenge. And it's not that hard to solve it, actually. It's very simple. There are multiple ways to do that. Of course, you could do a lot of DOM manipulations externally and try to do some of that. You could provide hooks in your applications, well-known hooks, that some other application can refer to your app and do some extensions there. I'm in the camp that as much as I would like, I don't want to do it all customization to everyone, because if I've built an app and I've designed it very carefully for a certain user experience, especially on the mobile, I want to constrain a little bit what people can do. And then people go in and they want to change the entire user experience, then it can be a little bit of a problem for them, right, down the line. But at the same time, you want to provide them some extensibility that they can do what they want to do. So what the approach was that I put extension points in the applications, well-known extension points at certain places. If you want to add a table, you can only add it at this place of your, or any content that you want to add a tab or something, you can add it here, here, and here on the screen. And these are very well-known extension points. Now, as a person who's going to extend this application, a customer or a partner or whoever, they go in and they write a new application which refers to my original application, and then they implement that extension. So as a developer, you probably know what is an interface and an implementation, correct? So think of it that way. You provide a web application with well-known interfaces in there, and then as a customer or somebody who's going to consume my application, I can go in and write the implementation for those interfaces. So I've kind of defined and controlled what you can do, but you can do a lot. And coming back to this, which I skipped over. So this is a definition file where I'm doing this. My original app, my original view, so model view controller, my original view is called view extensions. Sorry, I want to do an extension on my view, and my application.detail view is the name of my view. And in there, I have defined a well-known extension point called ext task list, for example. It could be anything, right? It's just a string. And this is all happening in the extension application. So you go in and you say, this point that you've defined in your application, this interface called extension task list, I want to insert a new fragment with the name of my extension and this name, ext list. And so at that very well-defined point, in the screen you saw that empty space. In my code, at that empty space, I would have defined a tag, an HTML tag, which is called ext task list. And the person who's implementing the extension would go and say, wherever that task list thing is, go and put this view instead. And this view, by the way, has the code to render a table. So this is how you would do it. This is one approach to do it. I found it to be very powerful. It serves most of the things that can be done. So as we talked, there are original hook points you provide in your original application. Hook points you provide. You can then refer to those hook points and do the implementation behind those hook points and implement new implementation for that. However, that's just how you extend. At runtime, it aggregates both these things. There is DOM manipulation, and then it renders on the browser. But there's another way to do that, because when you're doing all this DOM manipulation at runtime and rendering it like that, it's going to be a performance hit, right? Because you're doing additional work and all of this extra DOM work. What you could also do, and this is something I'm experimenting right now with, if you've written your extension and you have your original application, can't you just run a script that combines both of them even before you load your page? So even at my design time or build time, I combine all of that, and now when I load my application, I don't have to do that extra combining of all the DOM manipulation on my browser. Angular JS, it's a very popular JavaScript library. They have a concept of directives. They do something for extensibility and customization. It's not the same concept, but I like what they do. So that's one great reference point if you want to look more into that. It's directives on Angular JS. If you search, you'll see a lot of content. We just talked about this, so you could do this merging business either at runtime, dynamically, or which can also sometimes be error prone, right? What if there was a error in the code that you wrote in extension? It would be detected at runtime. Or you could just write a script which validates and merges it, and then you can load it later. And when you do extensions, don't forget, you have to also think of, if now you're going to render this table on your UI, You also have to extend your service, which is going to bring this content over to your UI. So you have to think of extensibility all the way through into your service and your backend extensions as well. Obviously, we'll not talk about those. Those are not part of today's talk. You have to know your service, what it returns, how it behaves. If you try to do too much on one page, maybe it's a huge performance hit, so you have to understand all of that. And many times I get this question, so I thought I'll just put it out there. Customization and personalization are not same things. Personalization is something you do at an individual user basis, so you will go and personalize the app, so you want to see something in a certain place. But Sam, who's your colleague, will not see that. He will see the original app, right? So that's at an individual user basis. Customization, however, is at a global basis within the enterprise context. So everyone sees that customized thing. Each role for which it is customized would see that. So that's a difference. Most of you probably know that, but I do always get that question. So we've covered a lot of ground. Just some more things I want to share with you very quickly. What else have you learned? So design is very important. Have your applications design driven. Approach it from that perspective. Things are changing very quickly, so have isolation in your architecture so that if the UI technology is going to evolve, then you can replace that without necessarily having to re-architect everything. During development, web-based applications, in my opinion, are much faster to develop, test, maintain than native applications. Badge reads and writes are very fast, much faster, because you know what, when you're doing a network I/O on your phone, it's just not making a call and getting data. It has to first negotiate a connection with the service provider. And the time that your phone takes to do that, it could vary from phone to phone, but it's something like between 500 milliseconds to a second sometimes, which is huge. And if you're going to make multiple requests, when you could make one request and the antenna goes to sleep, it has to wake up and renegotiate that connection, and that extra time is there. So that is something not everybody always thinks of. Application extensibility, you have to think of it if you're doing enterprise applications. This is one thing we've not talked too much about, but declarative programming sometimes is awesome and great, and I like it. I'll show you a very quick example if you're interested in it after the talk. I have a slide here, and if anyone is interested to know what that is, we can talk about it. But basically, for example, you have navigations, right? I'll give you a very quick example. You click on a button, and then you have on button click, and you have a handler, and then on button click, you handle what it needs to do. You do that, and then you navigate the user to another page. That's one way to do it. Another way to do it is you have one file where you define all the URL patterns, and when you click on a button, of course, you're filing a URL, and you detect it, and in that one file, you say, if this is the URL pattern, then load this page. So everything is defined in one place. When you do application extension, you can just extend that one file and change the navigation pattern. If it's all over your application, it's going to be impossible to change that flow. So extending your application and making your application something that can adjust to different scenarios is much simpler when you do declarative for some of the things. It's not something you do for everything, but for some things it's great. Since you're going to support multiple form factors, do a lot with JavaScript, you need to have rockstar CSS developers, and you probably know that. You have to use a combination of a lot of different JavaScript libraries. There was no one big JavaScript library which can do everything. For scrolling, you might have to use something. For carousel, one another thing. For fixing the thing at the bottom of your screen, yet another thing, and so on and so forth. For graphs, you have to use something else. And you will spend a lot of time doing that. You could do hardware acceleration to use your GPU by using something like WebKit transform. That's a great performance technique that you can do. So it doesn't use your CPU for rendering, but it uses your GPU, which is what CSS should be rendered through. And all phones have GPUs these days. Your applications have to be supportable. Make sure you are testing on your mobile devices early on, and don't just think it works on your desktop, and it works because of all the problems we saw. Rendering problems and performance problems are always going to be there. So, sorry, I rushed through some of the content towards the end. I'll be happy to discuss it if you want to talk about it, but we'll run out of time, and I wanted to give some time for questions. Thanks for being here. Thanks for listening to me. I appreciate your time.